All right, let's dive right in and pull back the curtain on programming. Now, I want you to forget any intimidating images you might have of crazy, complex code. At its heart, programming is really just a new language, a tool for you to create, to build, and to bring your ideas to life. So let's get started. I mean, it really does feel like magic, doesn't it? You collect a coin, and boom, your score instantly goes up. Well, that's not magic, it's code. And that's exactly what we're going to unpack today, using a world I think you'll find pretty familiar. So, to make sure this isn't just a bunch of abstract ideas, we're actually going to build something together. We're going to write the very first few lines for a simple game we'll call Cosmic Critters. And every new concept we learn will be another piece of our game's puzzle. So, where do we start? At the very, very beginning. You see, any computer program, no matter how complicated, is simply a set of instructions. Think of it like a recipe that a computer follows perfectly, step by step, without ever messing up. And that brings us to our first key term. A program is the whole recipe, right? And a statement, well, that's just a single step in that recipe. Like add flour or preheat the oven. It's one single, complete instruction for the computer to follow. And here we go. This is our very first statement for Cosmic Critters. This line tells the computer to do one specific thing: print a welcome message on the screen for the player to see. That's it. Simple as that. Now, let's just quickly break that down. The println part is the procedure. That's the action word, the command we're giving. The text inside the quotes, that's the parameter. It's the specific info that the command needs to do its job. And the whole line, from beginning to end, is one complete statement. Okay, so our game can say hello. That's a great start, but let's be honest. A game needs to remember things, right? Like your score, or how many lives you have left, or your character's name. So how does a program keep track of all that information that's constantly changing? The answer is something called a variable. And honestly, the best way to think about a variable is just as a labeled box. You can give the box a name, like score, and you can put a value inside it, like the number 0. Here's what that looks like in our code. That little word var tells the computer, hey, I'm about to make a new box. We're giving our box the label score, and with that equal sign, we're putting the starting value of 0 right inside it. And this is basically what's happening inside the computer's brain. It sets aside a tiny piece of its memory, slaps the label score on it, and stores the number 0 there. So now, anytime our game needs to know the score, it just goes and looks inside that labeled box. Now, what's really important to get here is that computers follow instructions in the exact order you give them. As you can see, first it creates the score box and puts a 0 in it, then it creates the lives box and puts a 3 in it. When we tell it to print the score, it shows us 0. But then, look, we update the score box to hold a 5. So the next time we tell it to print, we get the new value, 5. And hey, don't get too hung up on the specific word var or the semicolon at the end. Whether you're typing code like this or using visual blocks like you see here, the core idea is exactly the same. You're creating a named container to hold information. It's a universal concept in all of programming. So, we can store numbers. That's great. But what good is a score if it never changes? Our game needs to be able to increase the score, right? Well, to make that happen, our program needs to do a little bit of math. And here are the tools for that job, our basic arithmetic operators. Plus, minus, multiply, divide. They work just like they do on a calculator. We can use these to create mathematical expressions that let us change the values we've stored in our variables. So let's see how this actually works in our game. Imagine the player just grabbed a power-up worth 100 points. We write this line of code that basically tells the computer, hey, go look at the current value in the score box, add 100 to it, and then put that new, bigger result back into that same score box. This one line is how a score changes as you play. Okay, our game is really starting to take shape. We've got scores, we've got lives, but it's all a little impersonal, isn't it? We need words. We need them for the player's name, for messages on the screen, for instructions. Programs have to work with text, not just numbers. In programming, any piece of text is called a string. You can think of it as a bunch of individual characters all strung together. Now, the most important rule here, and I mean the most important, is that strings are always surrounded by quotes. That's how you tell the computer, hey, treat this as literal text, not as a command or a variable name. And just like we did with our score, we can create a variable to hold a string. So here, we're making a new box, a new variable, called player, and we're putting the text gray fox inside it. And notice, we've got those essential quotes. Now, what's really cool is that you can also use the plus sign to combine strings. With text, it's not addition, obviously. It's a process called concatenation, which is just a super fancy word for chaining them together. Here, we're combining the literal string, hello, with whatever value is inside our player variable to create a nice, personalized greeting. Okay, pop quiz time. Let's see if this is clicking. Imagine we've got a variable called nickname that holds the string splashy pants. Take a look at the options. Which one of these lines of code is going to correctly create the greeting, ahoy, splashy pants? And the correct answer is B. If you chose B, you nailed it. You definitely need those plus signs to chain the pieces together. But just as important, and this trips up everyone at first, you need that space inside the quotes after ahoy. If you forget it, the words will just get jammed together. In programming, those tiny details really matter. Wow, we've covered a lot of ground. Instructions, variables, expressions, and strings. So now let's put all of these pieces together and take a look at the complete script for our little cosmic critters game so far. And here it is. Look at that. Our program actually tells a little story, one instruction at a time. It starts by welcoming the player. Then it sets up the game's memory, creating our variables for the player's name and their score. It uses that concatenation trick to say hello to Gray Fox personally. Then something happens. The player finds a power-up, and the score is updated using our expression. And finally, the new score is printed for the player to see. It just flows logically right from the top to the bottom. And that's really it. Statements, variables, expressions, strings. These few simple ideas are the absolute fundamental building blocks of almost every single piece of software you use every day. The most complex app, the most beautiful website, the most incredible game, they all start with these same core concepts. So the real question isn't how it works anymore. The real question is, what will you build?